Yeah, is it visible?
Yeah, it's visible.
So the first question was identify. First, try to do by yourself. Okay, then
Okay.
I will tell you the solution. You have to identify the order of reaction when units are given. Units of rate constant are given. First question, it's liter per liter mole per second, and the second was liter per mole per second. Do that question.
Okay.
Equate the given unit of rate constant by the general rate constant unit. Okay, just
Okay.
equate that. Something will cancel out, and you will get the solution. That's very easy.
Okay. The general formula unit is mole per liter per second, right?
No,
No?
it's rate constant. रेट
Rate con.
कांस्टेंट का जनरल फॉर्मूला क्या होता है मोल पर लीटर
Oh,
1 minus
mole per
n per
liter, 1
second.
minus n.
Yeah, mole per liter per second was the general unit for the rate. Okay, rate of reaction.
Okay.
Because rate is nothing, it's the change in concentration with respect to time, right? And the concentration unit is mole per liter, and with respect to time, it's second. So that's why mole per liter per second. What is the
Okay.
unit of rate constant? So see, we know the general unit is mole,
So the first one is the first order reaction.
or let's check whether you have done it correctly or not. So it's 1 minus m per second is equals to, just equate this, right? So the given is
Yeah.
per liter mole per second, right? Now see, something will cancel out, per second will cancel out, right? And you can write this. Just see this mole per liter. This is the base. You have to arrange the right hand side according to this base. So you can write mole per liter, right? And what will be the power here? Again, 1. So you can see
One.
the base is same. So you can write 1 minus n equals to 1, right? So n will be
Yeah.
equals to 1 minus 1. So it's a zero order reaction.
Okay.
Yeah.
Yeah,
So
I
it's a,
see where I went.
yeah. So n is equals to 0. So it's a order will be 0. Okay. Similarly, let's do this. So mole per liter 1 minus n per second. Okay. Mole liter per mole per second. Okay, now just arrange this according to this base. You have to rearrange the right side according to this base, mole per liter, right? So how we can
Yeah.
write? You can write just mole per liter. Now see, what will be the power here? See, the power is per mole, right? So if you write minus 1, so it will be correct. When you open the bracket, it will be per mole and liter, right? So minus minus, it will be plus. So it will give you mole per liter. Okay, so we can write the power minus 1 per second. Now see, the base is same. This will cancel out, right? And the base is same, so you can equate the powers. 1 minus n is equals to minus 1. So in this case, what will be the power? So from here, n is equals to 1 plus the second order reaction. Got it?
Yes, ma'am.
Yeah, so accordingly, you have to do this type of question. Just remember the general unit of rate constant. Okay, and you just have to equate those terms and something will cancel out and you will get the answer. Okay, that's very
Okay.
easy. Next question. Okay, see, this is very important type of question. So for suppose 2a plus b, and you will get some product, right? Because for the rate of reaction, we don't need some product because हमें reactant से deal करना है, right? So for 2a
Yeah.
plus b, they will react to form some product. First part of the question is when concentration of A double alone, right? So rate increases 8 times, right? Just a second, not 8 times. When the concentration of A alone doubles, so the rate of reaction increases 2 times. 2 times.
Yeah.
Second part is when concentration of A and B both doubled. So in this case, the rate increases 8 times. Okay, but in this case, you just have to write down the rate law expression. Rate law expression. Also find the order. Find order of reaction. Okay, so it's just
Yeah.
opposite. We have done discussed this type of question, but in that question we have to calculate the increment or the changes in the rate constant, right? But here you have to write down the rate law expression and the changes is given, right? The concentration changes given because first part में क्या दे रखा है? So concentration, when the concentration in double, when you do the concentration of A double, so the rate increases 2 times, right? But the second
Yeah.
part is when the both the concentration are double, so the rate increases 8 times. Okay, so in this case, just write down the rate law expression and also write down the order of reaction. Just write by yourself first. We don't know the rate with respect to A and B, so just write down the X and Y, right? The power will be X and Y because we don't know the order of
Okay.
the reaction. Yeah, we have to find out the order of reaction. Once we got to know what is the order of reaction, you can easily write down the rate law expression.
Okay. Yes, mom.
Now, first, have you written the initial rate law?
Yeah, I have. I wrote the equation. Rate is equal to K into A to the power X Pt power Y.
Okay. Now, let's see the first part. In the first part, what are the conditions given? Only A is double. The concentration of A is double, right? So,
Yeah.
suppose R1, okay, because the rate also becomes 2 times. So suppose the initial rate was R1, right? So R1 is equals to 2R in the first case, right? When you increase the concentration of A, right? So R rate of reaction also becomes double. Okay,
Yeah.
so R1 is equals to 2R. When A1, okay, I'm writing R1, A1, and B1 for the first part. Okay,
First,
yeah.
first case.
Yeah, so it's 2A, suppose it's given, right? And B1, it it is as it is, right? Because its concentration is neither increasing nor decreasing. So as it is, B1 is equals to B. Now write down the rate law.
So we write R1 is equal to or
Yeah. Yeah. So R1 is equals to K, right? A1. raised to the power x and b1 raised to the power y, right? Now just substitute these values here. So
Okay.
r1 is equals to 2r, right? So 2r is equals to k into what is the a1? So a1 is equals to 2a raised to the power x and b1 as it is. Okay. So suppose
Yeah,
this
but
is the equation. Yes.
I have a question. In the top, the given reaction to us is having 2A.
Yeah.
It's
Yeah.
having 2A. So then how does that work? Do we not consider the two um, stoichiometry in the start, beginning?
Yeah. See, 2a. Right. I just told you it is not given here that it is elementary reaction or complex reaction, right?
Yeah.
It's not given here because we don't know the order of reaction with respect to A and with respect to B, right? So in that case, always write down the X and Y because we don't know whether it's elementary type
Okay.
of reaction, complex type of reaction, we don't know, right? So order is unknown here. In that case, just write X and Y. Okay, and X, I just told you earlier also that X and Y might be or may be equals to the stoichiometric coefficient, or sometimes it may not be equals to the stoichiometric coefficient. Right? That's why I have written X and Y here. Okay.
Yes, ma'am.
Okay. Now see the second equation. Let's suppose this is the second equation. Now see, we have first equation. Yeah, and you can write the initial rate equation is R, right? R is equals to this. And the first, for the first case, just write down the R1. And for the second case, we will write down the R2. Okay, so we have two equations, equation number 1 and equation number 2. Now, just equation number, divide equation 2 divided by equation 1. Okay, so 2R upon R is equals to, right? So K 2a raised to the power x, concentration of B raised to the power y. Okay, first one, it's A raised to the power x, concentration of B raised to the power. Okay, so always just divide the larger one with the smaller one. So the larger one is 2r, 2r divided by r is equals to this. Now see, something will cancel out here, r will cancel out, k will cancel out, right? And from here you can write, yeah, see, you can write this as 2, 2 multiplied by a, right? So it's 2 raised to the power x into concentration of a raised to the power x upon b raised to the power y, right? Upon your a concentration and b
We cannot
concentration.
cancel B and B,
Which one?
the B to the power Y and B to the power Y. We
Yeah,
cannot
yeah, we
cancel.
can cancel. We can cancel. We can cancel. We are going to cancel it here, right? Because I have just 2a को मैंने split करके लिखा है, right? I have written 2 raised to the power x into concentration of a raised to the power x, right? So everything will be cancelled and we have got 2 raised to the power x is equals to 2, means 2 raised to the power 1. And we know that according to exponential rule, when the base is same, so you can equate the powers. X is equals to 1. Okay?
Yeah.
So the order with respect to concentration of A is 1. Okay, हमने X निकाल लिया order of A with respect to, so its X is here. Now, let's say the second case, right? So in the second case,
Yes.
R2,
When
yeah,
solving the second case, will we substitute the value of X?
yeah, we can substitute the value of X and we can find out the Y.
Okay.
Okay, so see, R2 will be equals to, in the question it has been said that when the concentration of A and B both are doubled, the rate becomes 8 times. So R2 will be 8R, right? When A2 is equals to 2A, right? So you can write a concentration over here and B2 concentration will be 2B. Okay, now rate law laga do. So rate law will be R2 is equals to K into A2 raised to the power X and B2 raised to the power y. And now don't substitute the value of x here, right? Don't substitute the value of x here,
Okay.
right? In the last we will substitute the value. So R2 is equals to 8R, right? Now K will be equals to 2A raised to the power x, 2B raised to the power y. So 8R will be K into, when you split this, 2 raised to the power x into concentration of A raised to the power x. And this also, so 2 raised to the power B, concentration of B raised to the power y. Okay, so let's suppose this is equation 3. Now just divide the
The
equation. Yeah, just divide 3 equation by 1. So 8R upon R is equals to K into 2 raised to the power x into 2 raised to the power y, concentration of A raised to the power x, concentration of B raised to the power b, upon your K, concentration of A raised to the power x. Yeah, see, everything will be cancelled out, and you will get 8 is equals to 2 raised to the power x into 2 raised to the power y. Now, according to exponential rule, we know that if the base is same, right, and they are in multiplication form, the power will be added up, right? And we can write 8 as a, we can write 2 raised to the power x plus y is equals to 8 is 2 cube, right?
power 3.
Yeah. So the base is same, so we can equate x plus y is equals to 3. Now we know the value of x, okay? So 1 plus y is equals to 3. So y will be equals to 2, okay? Now if y is equals to 2, so we know the order. Order will be equals to, order means n. And will be equals to the
Yeah.
powers of both x plus y. So it means 1 plus 2. So the power order is, okay. Similarly, you can write down the rate law expression. Rate law expression. Okay, so rate will be, just substitute the value of x and y in the equation number 1. Concentration of A, and x key value is 1. Concentration of B is to the power 2. Okay, so that's the value of rate law expression. Clear? Understood?
Yes. Yes, sir.
Okay. So you have to do this type of question. Okay, आप कर सकते हो ना? Okay,
Yes,
now,
I can.
okay, very good. So next is your initial rate method to determine order and rate law expression. This is again very important. Okay, you will see in any type of exam, you will see this type of question. You will be given a question in the type of tabular form, right? The data will be given in the tabular form. So according, let's see the questions ke according we will discuss it. So initial rate method to determine order of reaction and rate law expression. Suppose, so basically this type of method always we will do when the question, just a second, when the question is, basically it's a box problem or table type of data problem. The information is given in the tabular form. Okay, so let's see the some numericals. So suppose question is, when 2NO, it reacts with Cl2, so it will give you 2NOCl. Okay, so reaction will be given first. Okay, I just draw the box.
So this is just another method.
Yeah, the another method to determine the rate of reaction. So basically rate of reaction or rate law expression. So basically we can define the rate, or we can calculate the rate of reaction by many methods. Okay, the integrated method, which we have discussed in the first class,
Yeah.
integrated method, the d upon dt. So that was the
Yeah.
integrated method. Second method, the rate law expression, right? From the equation, we just put the stoichiometric. So that type of method. Third method is your initial type of method, initial rate method. So here the experiment number is given, right? Initial concentration of NO reactant, and which is in molar concentration, right? So it's a molar concentration, and initial concentration of Cl2 is given. Again, it is in molar. And here the initial rate of disappearance is given. Rate of disappearance of Cl2 is given, right? So basically there are 4 experiments here. 1, 2, 3, and 4. Okay. For the first experiment, we found that initial concentration of NO is 0.15 molar, and the initial Cl2 concentration is again 0.15, and initial rate of disappearance is 0.60, and this is 0.15 again, 0.30.
So this is given to us in the question.
Yeah, it will be given 0.30.
That's molar mass of NO2, right?
Yeah,
And of Cl2.
not molar mass, it's molar concentration.
Oh,
Yeah, molar concentration and molar mass both are different terms. So, rate of
what's
disappearance
the
of
difference?
molar mass is basically, see, we have molarity. Molarity क्या होता है? The number of moles, right, divided by
Yeah.
the volume, right? So this is your molarity, molar, right? And molar mass is basically, for example, like CH4, right? So when you combine all the masses of elements, so we get the molar mass. Suppose the atomic mass of carbon is 12, right? And only one carbon is there, right? One carbon is there, so 12 plus 1, plus atomic mass of hydrogen is 1 into 4, right? So 12 plus 4, basically 16 gram per mole. So this is a molar mass, right? So basically molarity is a number of moles, and number of moles is dependent on the molar mass, right? So you can't say the concept molarity and molar mass are same, right? Molarity is dependent on the molar mass, right? Because number
Yeah.
of moles, how we can calculate the given mass upon molar mass, given mass upon molar mass. That's
Molar.
how we can, yeah, we can calculate the number of moles. So both are different terms, right? Molarity
Okay.
means molar concentration means the molarity is given. Molarity is given. Okay. So the initial rate of disappearance in the third experiment is 2.40, and the fourth is unknown, right? It is not given in the question. In the fourth experiment, the initial rate of disappearance of Cl2 is not given. Okay, now let's see the question. First question is, write the expression of rate law. Rate law. Second question here is, calculate the rate constant and order. Third is your, what is the what is the initial rate of disappearance of Cl2 in experiment number 4. Okay.
Yeah.
Okay, let's see how to do this type of question you have written.
I'm writing the second, write the expression of rate law.
Okay, correct. First, write down the integrated rate equation, right? For all the means the rate of disappearance of all the reactant and the rate of appearance of your NOCl product.
Okay.
So we have the equation 2NO plus Cl2 will give you 2NOCl. Okay, let's write down the integrated rate equation. So rate of reaction will be equals to, we know, minus negative sign, we just put in
For
the
the
reactant.
reactants.
Yeah. So D, concentration of Cl2 upon dt, right? This is for Cl2, right? So you can see there is a
Yeah.
stoichiometry is 1. So that's why the rate of reaction, we can say the rate of reaction is equals to the rate of disappearance of Cl2. Can we say that? Because here is no
Yeah.
coefficient. If there is a coefficient over here, so we can't say that the rate of reaction is equals to the rate of disappearance of Cl2, right? But here is only one coefficient, so we can say that the rate of disappearance of Cl2 is equals to the rate of reaction, right? So in this question, we can say that, see, this is the table, right? So initial rate of disappearance of Cl2 is given, right? And from this equation, we know that the rate of reaction is equals to the rate of disappearance of Cl2, because basically it depends on the stoichiometry, and the stoichiometry here is 1, right? So you can see if the rate of reaction, suppose it's 2.2 into 10 raised to the power 3, so it will be equals to the rate of disappearance of Cl2, right? Because here there is no
Okay.
stoichiometry, only 1. अगर वहां पे stoichiometry 2 होता, so we have to multiply it by 2. The rate of reaction will be
Okay.
multiplied by 2, right? So in this case, we can say that this value, this initial rate of disappearance of Cl2, we can take it as a rate of reaction also for Cl2 in this case, right? So rate of reaction, we can consider it, but not for all the type of reaction, right? If the stoichiometry is 1, right? So we can suppose that we can assume that that is the rate of reaction.
So for this question, the
Yeah,
last column is also equal to the rate of reaction.
yeah, yeah. Okay. So it's minus d upon dt upon Cl2, which is equals to, this is 1 minus 1 upon 2 d upon dt of NO, which is equals to 1 upon 2, right? D upon dt of NOCl. Sorry, this is not Cl2, this is NOCl. NOCl, right? So basically, what is this? So this is the rate of disappearance, disappearance of Cl2. This is the rate of disappearance of NO, and this is the rate of appearance. That's why we have put plus sign over here. The rate of appearance of NOCl. Yeah. And the rate law, just write down the normal rate law expression. So rate law expression will be rate is equals to K, right? The concentration of NO raised to the power X, because we don't know again, we don't know whether it's an elementary type of reaction or complex type of reaction. So we just put X because the order is unknown. Cl2 raised to the power 5. Okay, so we have written both the type of rate, rate of reaction will be given by this also, and rate of reaction will be given by this. Okay, now see, So the rate law expression from 1 and 2 experiment, how we can write down 1 and 2 experiments. Just write down the rate law. So R1, suppose for first we are writing R1, the rate will be R1, rate constant multiplied by the first concentration, the concentration of NO, which is 0.15 here, raised to the power X. And again the concentration of Cl2, again it is 0.15 raised to the power Y. And the rate is given because we have seen that the rate of reaction is equals to the rate of disappearance of Cl2 in this case. So we can write it's 0.60. Okay, this is for the equation for the first experiment. See the data over here. Okay, so it's the initial rate
Okay.
NO 0.15 and is 0.60. Okay, so just mark it as equation number 1. Similarly, write down the rate law expression for second experiment. So what will be it? R2 is equals to rate constant into the concentration. Concentration is 0.15 again, raised to the power X, right? And what is the concentration? Yeah, so for Cl2, it's 0.30 raised to the power Y. And what is the rate which is given? So rate is 1.20. Now mark it as equation number 2. Okay.
So
Now
do we
see,
divide again?
yeah, again, just divide. See, I will give you some trick over here. So if we are just calculating, just if we are taking the rate law expression from first and two experiment, because here four experiments are given, right? So you have to take which type of that experiment whose values are same, right? For suppose
Mm-hmm.
first in the first experiment and second experiment, the initial value of your NO is same, right? So that why we are taking this common, because this will cancel out. When you divide this, this will cancel out and you will get the value of Y. Okay. Similarly,
Easily.
yeah, easily we can just calculate the value of order, right? Similarly, if we are just calculating the another we are taking the another experiment, so similarly you can do the same. Just suppose in the initial value of Cl2, suppose in the first experiment and the third experiment it is same, so just take one and third experiment, just divide it and this will cancel out and you will get the value of X over here, right? So when you take the two conditions, two cases, like in first case, just divide the equation number 1 and 2, right? In the second case, just divide the equation number 1 and 3, right? So in
Okay.
from these two, you will get the value of X and Y. So order will be known, right? Order will be
Okay.
okay. So let's do that. Okay, and always just divide the larger one with the larger one,
Smaller.
yeah, with the smaller one. So just divide 2 divided by 1. Write down K 0.15 raised to the power X, 0.30 raised to the power Y. K 0.15 raised to the power X, and again is 0.15 raised to the power Y. 1.20, 0.60, right? All will be cancelled out, right? So 15 ones are 15, 15 twos are, right? And see, here, this 2 raised to the power y, and here the 1 raised to the power y. So we know that in these two conditions, we can write 2 upon 1 raised to the power y, right? So you will get 2 raised to the power y here, 2 raised to the power y. And this will be,
Yeah.
it's 2. Now see, so here, 2 raised to the power y is equals to 2 raised to the power 1. So from here, y is equals to 1. It's very simple. Similarly, do the next. Just take the experiment number 1 and third, divide both of them, right? And you will get the value of X. Any doubt, Riddhi?
No. I just got confused because the 0.30 upon 0.15, both of them are to the power y, right? So I got confused. I didn't know we can divide.
Okay, okay. Yeah,
Yeah.
see, because both have the same power,
So we can
0.30,
divide.
right? And it's
Yeah.
0.15 raised to the power y. Now, it's a law of exponents that if the
Yeah.
power is same and they are in divided form, so we can write, see, we can write 0.30. We can take the common power. If the power is same and they are in divided form, base is different, right? See, if I write a raised to the power m upon b raised to the power m. See this Riddhi here.
Yeah.
See this. So we have done this in the earlier classes, right? So this is a law of exponent. So when the power are different and the power is same and the base is different and they are in divided form, so the common formula is a upon b, and we just take the common power.
Yeah.
Yeah,
That's
so
what I got confused for a second, and then I
yeah,
realized.
okay. So you will get 2 raised to the power 5. Similarly, rate law from one equation from one and third experiment. Write down the, because we have written the first one, right? Rate law for the first experiment we have written, which is equation number 1, right? So just write down the
Yeah.
R3. Okay, so no need to write it again. So R3 will be rate constant into concentration is 0.30 raised to the power x into 0.15 raised to the power y. Mark it as equation 3. Now just divide 3 divided by 1. Equation 3 divided by 1. A 0.30 raised to the power x now 2 raised to the power x is equals to, we can write 4 as 2 raised to the power 2, 2 is 4. So from here, the value of x will be 2. Now you can easily
Yeah.
write down the rate law expression.
Uh,
First part,
I I did it with equation 3 and 2. So I divided 3 and 2. It was a little more complicated than this. You could
yeah,
easily
yeah.
cancel it out.
That's why, yeah. It will be, you will get the same answer, but
Same
it will be
answer, but
little, yeah. But you will little bit, it will be difficult for you to solve. It will take more time, right? That's why I
yeah,
just give you a trick. Just see when the same, you just take, you have to see the same concentration term and just take that
yeah,
experiment, right?
yeah,
Do this trick also in exam. Okay, don't do the complicated thing. Okay,
yeah. Okay.
okay. So the rate law expression, now you can easily write down because we know the order of reaction with respect to A and B, right? Means with respect to both the reactants. So NO raised to the power X, which is 2, and Cl2 raised to the power 1 because the value of Y is 1. Okay, now order will be,
Three,
yeah, tell me the order.
3 x plus 1,
Yeah, it's
which is
3.
2 plus 1, which is 3.
Hmm. Third order reaction. Okay, now just calculate the rate constant value. And yeah, same thing, rate constant value you can do for any experiment. You will got the same value. Like, let's see, we know the rate constant Basically, you can write down from here you can see the rate is equals to K into NO square, right, upon Cl2
Yeah.
raised to the power 1. So from here you can write rate constant K is equals to rate upon concentration of NO square Cl2 concentration 1. Now put the value from any experiment you can write. Okay, let's take the from experiment number 1. K will be, what is the rate? So it's 0.60. Concentration of NO is 0.15 square and Cl2 is again 0.15. Now let's solve this.
So this is from the
0.60.
first experiment,
Yeah, you can similar calculate it for the second one, third one, and so on.
which would be the same, right?
Yeah, it will be the same.
So we don't need to calculate for all.
Now, don't need to. Okay, just calculate the rate because the rate constant is for the overall is same, right? No need to calculate it for all the experiment. So 0.60, it will be 15 square is basically 0.0225 into 0.1. Now do this. Four thousand upon 225. So you will get something 177.7. And what will be the unit?
Uh, it'll be since it's a third order reaction.
So don't go to the order. See this. The rate upon the concentration. Two
Yeah.
concentrations are there, right? So
Yeah.
concentration is mole per liter,
Yeah.
right? Mole per liter, and the rate is what is the mole per liter per second?
Yeah.
Mole per liter per second. So what will be the overall? So it's
Per
mole
second.
per mole, right? Because in the constant in the
Okay.
denominator part there will be a mole, right? So mole per liter square per second. And similarly, you can, if you know the general equation, so you can easily.
So the unit of rate is mole per liter per second, and the
Now,
concentration is mole per liter.
yeah. Similarly, if you can, if you know the order of reaction, so and you remember the general unit of rate constant, so you can easily put. Put the value of n over here, 3, and you will get the
Yeah.
value, right? So just you can check it out whether your unit is correct or not from here, right? So it's mole per liter 1 minus your 3 per second. Mole per liter and 1 minus 3 means minus 2. Now see, so it will give you mole minus 2 and written minus minus it will be plus liter square. Sorry, it's second. Is it correct? Now check it.
Yeah.
Yeah, it's correct. So that's how we can calculate the unit also. Okay, what was the third question? Third question. Okay, so we have written the
The
expression of,
fourth experiment.
yeah, we have to calculate the rate of disappearance or rate of reaction for the fourth experiment. Okay, let's write. Now we have to use this. We have to use this one, right? Now the use of this equation. Okay, let's see. So what was the rate? Rate of reaction. Can we write? Because the rate of disappearance is given, right? So we can write down the rate
Yeah.
of reaction. We will only take the rate of disappearance of Cl2 because other information is not given, right? So we have to
Yeah.
calculate each and everything using that table only, that information only, right? So what is given? So d upon dt of Cl. Right, so what is this? This is the rate of disappearance of Cl2. Okay, now see, so from rate is equals to A NO square and
We
Cl2.
can't find that rate with using the other rate law equation.
We can. Let's see we are going to do. Let's see. We will use that. Okay, we will use
Okay.
that table. Okay, so see, because we have to use the fourth experiment data. So from experiment 4 data, okay, so rate, we can write rate 4 or R4, simply write on the R4. R4 will be equals to the what is the value of K? So K value we have calculated, right? We have calculated the rate constant value, which is 177.4. Just put that value here, right? Now just use the value. What is given in the fourth experiment, the concentration of NO? So it's 0.25, right? Square. And now the concentration of Cl2 is, just check it. What is the given? Again, it's
0.25.
0.25. Yeah, again, 0.2. Okay, now just solve it. Just solve it and you will get the value of R4, 177.4 into, sorry, it's 7.
7.
Yeah, it's 7 we have calculated. Now it will be, you can write 0.25 into 0.25 into 0.25. Now just multiply it. Very complex. Okay, so the final answer will be 2.77. And what would be the, because it's a rate of reaction, right? So rate of reaction के लिए unit क्या होता है? It's mole per liter per
Liter.
second, right? If in a question, if they have given the rate of reaction in mole per liter per minute or per hour, so you have to use that unit only, right? But here
Okay.
no information is given, right? So we will use mole per second. Okay,
Okay.
but in the tabular form, they will give you something like this is in this unit, right? So just use that unit for the rate. So is it clear? Now you will do
Yes,
this
ma'am.
type of question.
Yes,
Okay.
ma'am.
Okay, one more question, a little bit different question. So consider the rate 2A plus B, which will give you C plus D. And the experimental data is given.
Another table.
Hmm. I'm just writing the A concentration. This is the initial one. Initial. Initial concentration of B. And here the initial rate of reaction. Yeah, here the rate of disappearance and appearance is not given. The directly given here rate of reaction. Initial rate of reaction, which is in mole per liter per minute. Okay, so just observe this unit. You have to write down the rate of reaction in this unit only, if the unit is given in the question.
Okay.
Okay, so 1, 2, and 3 experiments are there. 0.10, 0.10, and the rate is 1.5 into 10 raised to the power minus 3. Question 1 is write the rate law or the reaction. Second question is calculate a value of a rate constant or the reaction. Third is which of the following which of the following possible reaction mechanism is consistent. Little bit different question. So which of the following possible reaction mechanism is consistent with the rate law? Okay, first reaction is A plus B, and it is given that it is slow reaction, and A plus E, which gives you D, it is a fast reaction. It is given in the question. So from here, you can see that this is a complementary type of reaction, right? Because
Yeah.
reaction mechanism is given and there are two steps. One is slow and the second is fast. And the second option is B. It just decomposed to form C plus E. And this is your slow reaction. A plus E, it will give you F. Again, this is fast reaction. A plus F will give you D. This is again a fast reaction. Okay, so that's a question. Experimental data is given, right? And you have to write down the rate. First two questions, just do it by yourself. Just do it.
Okay.
Very
Can
simple.
I see the table?
Yeah, sure. First two questions, you can do it. It's just similar to the previous question.
Okay. Yes, ma'am. I didn't write the first two parts of the question.
I thought today we will we will discuss the zero order type of reaction. आज हम सिर्फ क्वेश्चन ही करते रह गए. Please try to do the homework, Riddhi. Just
Yes,
try
ma'am,
to do
I
it
will.
by yourself. जो भी मैं देती हूँ, just try to do it by yourself. If नहीं हो पाता है question, so just ask me in the class.
Okay, ma'am.
And yeah, if in any question or any experimental data, if the concentration in the two experiments are not same, somehow if it is not same, so you can just take any two experiments. Okay, no problem. But most of the questions we get there, they just give the similar concentration. So just check it out, which one is a similar, and just take that experiment.
Okay. Yes, ma'am, I finished the first two parts.
Okay, just tell me the value of x and y.
Uh, 2 and 1.
Are you sure? I don't think so.
Then my second part of the question is wrong.
What is the value of y? Y का बताओ मुझे.
Wait, I made a mistake. I'll try again.
Because see, it's the first order reaction, right? The value of
Yeah.
x will be 0,
Okay.
right? With respect to a, the value of the order will be 0. So overall will be the order will be first order reaction. Let's see. You have done.
I didn't do it like that. I made it. I messed up.
Okay, similar thing we will do. So the rate law expression, it will be k. Always write down the first general rate equation.
Yeah.
Yeah. Okay, let's see what is the. Okay, so you can see that in the second and third, they
I thought since this was a complex reaction, we could take the stoichiometric values as the power. So I solved it based on that.
no. I just
Yeah.
told you whether it's complementary or yours, just always write on the x and y,
Yeah,
right?
I got confused.
Okay, don't be confused in that. Just always take x and y if the
Okay.
directly order is not given, right? So
Okay.
rate is the general reaction will be this. So let's take the third and second experiment, right? For the ease. because the concentration are same in the first, second, and third, right? So R3 will be, it's 6.0 into 10 raised to the power minus 3, which is equals to K, okay, into
Yeah.
concentration is 0.20 for both of, no, it's right. So the first equation. So for R2, just similar, just write down 3.0 into 10 raised to the power minus 3. K, I think the value of concentration for the first is same. And the second for, yeah, second. Now just divide
Yeah.
larger one with a smaller one. Okay, so the equation 1 divided by 2 because this is larger, right? So 6.0 into 10 raised to the power minus 3. 3.0 into 10 raised to the power minus 3. This will cancel out and 3 2s are 6. Again, cancel, cancel, right? मैं यहीं पे cancel कर रही हूँ, so it will give you 2. So don't be confused in that. 2 raised to the power
Okay.
1 and 2 raised to the power y. So y will be equals to 1. Next, just take equation number 1 and 2. Because you can see in the equation initial concentration of B is not same. For each and every experiment, it's different. So you can take 1 and 2 also, okay, and 2 or 3 also, right? So we have taken 2 and 3, so we can take 1 and 2. 1 and 2.
Okay.
R2 is 3.0 into 10 raised to power minus 3. Suppose this equation, suppose it's 3. Or R1 will be equals to 1.5 into 10 raised to power minus 3. Is divided. 3 divided by 4. 3.0 into 10 raised to power minus 3 and 1.5 into 10 raised to power minus 3. Okay, so this will give you 2. This is, okay, and this will give you 2. So 2 raised to the power 1 is equals to 2 raised to the power x into 2 raised to the power y. Now, so 2 raised to the power 1 is equals to 2 raised to the power x plus y. So base is same, so x plus y is equals to 1, right? And we have just calculated the value of y. So y, the value just put karo isme. So it will give you x plus 1 is equals to 1. So here x is equals to 0, right?
Mm.
Now, first question. What, write down the rate law expression. So it will be A, concentration of A raised to the power 0, concentration of B raised to the power 1. Now anything raised to the power 0 is 1, right? So here you can see that the rate rate constant, it just depends on the reaction is, you can see the rate is 0, right? Because if the rate is 0, so the rate of reaction is just depend on the concentration of B, not the A. Okay, so you just asked me once what is the role of rate, why we use order, right? So that's the order. You can see if the order is 0, right? So the rate of reaction, it doesn't depend on the concentration of A because its order is 0. Right? So basically order क्या बताता है? It just tells us about the dependence, right? Dependence of that reactant in the rate equation, right? In the
Yeah.
chemical reaction. So basically the order हमें ये कहता है. So basically the rate is equals to rate constant into the B concentration raised to the power 1. That's the rate equation. Okay, so what will be the order of reaction? One order, first order reaction. And the rate of reaction, it just depends on the concentration of B only, not on the A.
Okay.
Second part, what was the second question? Now just calculate the rate constant value.
Okay.
From here, the rate constant will be equals to the rate upon the concentration of B raised to the power 1. Now just substitute the value. You can do, or you can take any data from any experiment. Let's take from experiment number 2.
Yeah.
Just taking experiment number 2. You can take any experiment. So 3.0 into 10 raised to the power minus 3.
Upon 2.0.
Okay. Okay, so you will get 15 into 10 raised to the power minus 3 per minute. You can check the rate constant value by the general unit. Because you can see the rate is mole per liter per second and the concentration is, sorry, here per second we will not
Per
use a per
minute.
second. Yeah, per minute. Okay, so and the concentration value is mole per liter, right? So this will cancel out
Yeah.
and you will get the value in per minute. Okay, so the rate constant value is in per minute. Okay, now here comes the third part, which is very important. Okay, so two options are given and we have to check on which reaction the rate, see, what was the question? So we have to check which of the following possible reaction mechanisms consistent with the rate law. We have rate law. Rate law is this, right? Rate law is just depends on the concentration of B only. And we have to check in which equation the rate constant is basically depend on the concentration of B only. So we have, see, just a second, let's see the, yeah. So you can see here, two step is given. And what will be the, I just told you which step is the rate determining step.
The slow step.
Yeah. So there is no need of this step. We will work on this only and this only, right? So just let's check it out for both the,
So would it be the second one?
yes. Yeah. It's, you can see over here, the only B part is there, right? B
Yeah.
reactant is there, right? And the according to us, the rate is dependent on the concentration of B only, right? So
Yeah.
second option will be correct. But in the exam, you just have to just check.
Elaborate.
Yeah, both options you have to check and write down which why it is not correct. This is the slowest step. And we know the slowest step is the rate determining step, right? So here you will
Yeah.
write down the rate equation. So rate equation will be A, right? Because it's a rate determining step, slowest step is given. So you can write, you can use the stoichiometric coefficient here, right? So just write.
Yeah.
Yeah, so from here you can write, you can see that that order is 2, which is wrong, right? This is wrong. So this is not consistent. The rate expression for this equation for this reaction is not consistent. Let's check for the second one. So B, it is just decomposed to give you C plus E, right? Again, it has been mentioned over here. This is the slowest step, means the rate determining step. And here, if you write down the rate of equation, rate of reaction, so you will find out that it just depend on the B concentration, right? So it is just
Yeah.
similar to the rate equation which we have derived here. So yes, this is consistent. This is consistent with with a given reaction. With given reaction. Okay, so is it clear now?
Yeah.
Okay, we have still 10 minutes, so we can jump into the zero order reaction.
Mm.
Okay, done? Written?
Yeah.
Okay, so we will discuss the basically derivation. Okay, so we will start with the integrated. Integrated. Do you have math in your subject?
Yeah, I have taken maths and
Okay,
computer science.
okay, so that's good. So that will be easy for me to explain it to you
Yeah,
because you know integration and differentiation.
yeah. And also
Integrated,
that it's there in physics.
yeah. So integrated rate law. First, because in your syllabus there is a zero order reaction, first order reaction, and pseudo order reaction. Okay, so three types of reaction we will see: zero order, first order, and pseudo order. Right? We will see how to derive the rate equation and what is the half life of this type of reaction. So we will see each and everything graph, right, which is very important. Okay, so one by one we will see. So first is your zero order reaction.
So under integrated rate law, there is zero
Yeah,
order reaction.
yeah. So zero order reaction, we know very well. The order is zero, right? The order is zero. So suppose A, it gives you B, right? And it is given that it is a zero order reaction. It is a zero order reaction. Means N is equals to zero. Okay, now let's write down the differential rate law. If I say differential rate law, you know very well, it's d upon the change with respect to time, right?
Yeah.
So differential rate law.
A to P or R to P?
Yeah.
Is it A to P or R to P?
Okay, we will discuss. Let's see, you will get to know. So
That's why I wrote
differential
A.
differential rate law. So just write down rate is equals to minus d upon what will be the concentration? So it's A reactant, right?
Yeah.
A upon dt, right? Mark it
Yeah.
as equation number one.
One
Okay,
second, ma'am. Let me catch up with you.
okay, just write down along with me because it's a very little bit time.
Yeah.
So rate is equals to minus the concentration of A with respect to time. Mark it as a first equation. Now, according to rate law expression, rate law equation, what we have? We have rate is equals to K into, write down this one, K rate constant in the concentration of A, because it's a zero order reaction. It is given. It has been mentioned over here. So we can write zero as a power, right?
Yeah.
Yeah. So now mark it as
So
equation
rate is
number.
equal to K.
Yes. Yeah. Now from equation number one and two, what will be it? So concentration of A dt is equals to A
K.
A raised to the power 1. And we know that anything raised to the power 0 is 1. Okay, so it will give you A only. Okay, now
Yeah.
just take take this dt over here on the right side. So it will give you K into
K dt.
dt. Now integrate both sides. Now integrating both sides with with limit initial when at the time t0, right? What will the concentration? So A concentration will be is equals to A naught, right? A naught is the initial concentration. Now
Yeah.
final, when T is equals to T, so the concentration of A concentration, it becomes 80. 80 and 80 is the remaining concentration. 80 is the remaining concentration because we know that when the time increases, what happens to the concentration of reactant? The reactant concentration decreased, right? Because
Yeah.
it been
It's being used up.
yeah, it's been consumed in the reaction. Okay, Okay, let's integrate. First, let's minus sign यहाँ लगा दो on the right side. So it's minus k into dt. Now integrating dA dt. This is minus constant outside. So from a naught to at. And from here, t is equals to 0 to t. Okay, when you integrate this, so you know very well this will cancel out and you will get concentration of A, AT, upper limit and the lower limit is A naught. Similarly, my constant term outside and you will get T, upper limit is T and the lower limit is 0. Now to substitute the value, so you will get AT minus A0 and this will give you minus K, T minus 0. AT minus A0, it will give you minus AT minus KT. Now, when you rearrange this, you will get AT is equals to A naught minus KT. A naught minus KT. Now, this is the integrated rate law equation for zero order reaction. You just have to remember this equation. Integrated,
The derivation will be asked.
no, derivation will not be asked. Yeah. So, integrated rate law. But in some school, they directly ask the derivation. Just ask
In
it. They
boards.
no, in boards, not in boards, but in a school
Okay.
exam. Mainly numerical type of question has been will be asked, or yeah, graph is very important. Directly, they will give you the graph and they will ask you which order reaction is this, okay, and write down the order of reaction and what is the rate constant value, not the value, what is the unit of rate constant. Okay, if the order
Okay.
is known, so you can easily find out the unit also. So integrated rate law
For zero order.
equation for zero. Yeah, and write down where A naught is initial concentration of reactant A at time zero, at initial time, which is zero. And what is AT? AT is the concentration of A at time t. It means the remaining concentration. The remaining concentration. And what is K over here? So K is, you know very well, it's a rate constant for a zero order reaction. And time is, T is time in which concentration change from A naught to A. Clear? So
Yeah.
we will see the graph and there is a special type of zero order kinetics we will see in the next class.
Okay, ma'am.
Is there any doubt in today's session?
No, ma'am.
Oh, okay, so have you written?